This is going to be one of a kind, unique show. I'm really looking forward to get going with the discussion today. Yes, folks, welcome to episode 4 Unveiling DevOps at AWS on your favorite YouTube channel. This is the AWS Cloud Operations Show where problems meet solutions. I'm the host, Imaya Kumar Jagannathan. I lead a team of worldwide specialist solution architects that focus on cloud operations. I'm streaming live today from Atlanta, Georgia. When we say problems meet solutions, we actually mean it, right? As you have seen in the last few episodes, we had many opportunities to actually discuss and demonstrate solutions for real world problems in the cloud operations domain. Today, we have a very unique guest on the show, and we are going to explore all about DevOps practices at AWS. As far as I know, this is not something that we have spent a lot of time talking about on another medium. That's why I'm really excited to listen to what our guest has to say. Without further ado, let me invite my special guest, John O'Shea, on the show. And along with me, I also have Anya Develter, Senior Specialist Solution Architect, to discuss this topic. Folks, welcome to the show. Please introduce yourself to the audience.
Hey, Anya. My name is John O'Shea. I'm a senior principal engineer. I've been working for Amazon or for AWS for about 15 years, just nearly 15 years actually. And I'm based in Dublin in Ireland. And I work on AWS CloudWatch, which is the monitoring service that AWS provides to our customers. Hopefully I have some insight into how we do DevOps, having been here for a little while.
Hi,
Thank you.
everybody. Hi. My name is Anya Develta. I'm a specialist solutions architect. I work on the same team as Amaya. He's my manager. So that's the worldwide cloud operations team. I've been at AWS for just almost 6 years, and I'm based in Newcastle in the UK. And day to day, I talk to customers about observability, the observability challenges, the observability tools. So I come from a DevOps background, and I'm really excited to talk to John today.
Awesome. Thank you. Thank you both. I really appreciate you for being on the show. So this is to the audience. The really important point that I want to make before we begin is that in the past episodes, we showed real-world examples through demos. We shared the AWS console on screen to help you understand how you can solve specific use cases, right? But this one's going to be quite different, right? As we are not going to focus on a specific feature or a service or anything like that, but we're going to talk about the DevOps concepts and practices that are used at AWS. DevOps, if you think about it, it's all about culture, process, taking actions, owning responsibilities, etc., more than a particular tool itself. So it's about how you set to operate than what tools you use to operate. Learn from this discussion here and implement the ideas in your environment. And also, by the way, please ask questions along the way. We want to make this conversation interactive. Kindly make your questions relevant to the conversation happening at that moment, so we can include that observation or a point as part of the discussion. All right, intro's done. The stage is set. John,
Okay.
Thank you once again for being on the show. Anya, thank you to you as well. John, I just mentioned about culture, right?
Yeah.
And why it is important. Can you expand on that and on that part and how AWS looks at it?
Yeah, for sure. Yeah. So I joined, like I said, about 15 years ago. And when I joined AWS, AWS itself was maybe about 6 years old. I think the first AWS services launched in 2004, right? So SQS, I think, was 2004. S3 and EC2 launched in 2006. And CloudWatch, the service that I work on, actually launched literally about 2 months before I joined in 2010. So I kind of came in just to celebrate the glory of the launch of CloudWatch, and then I've been working on it for 15 years since then. The culture hasn't changed a huge amount since way back in 2002 in Amazon. And one of the probably driving forces behind the culture in Amazon is a mandate that Jeff Bezos kind of passed down back in 2001 or 2002, which is really about how Amazon builds services and how we operate our services. So Amazon Retail was obviously a few years old before 2001, and they had created the bookstore using this kind of monolithic architecture, and they had all of their engineers, all of their people working on one application, which was basically the retail book website. But in 2001, that was kind of causing, I suppose, issues in terms of being able to iterate quickly and deliver value to our customers. So Jeff basically kind of created this mandate which said we had to decompose from these monolithic applications and teams and switch to kind of a microservice based architecture and these kind of two pizza teams. And that culture, that was the start. That was like 22, 23 years ago, I guess, at this point. And we're still pretty much operating in the same principles that, we build kind of microservice-based systems, and we have these kind of small, independent two pizza teams that are doing all the work. I think that's one of the reasons why Amazon and AWS was such an early kind of innovator in terms of like creating a software development and an operational process that kind of was DevOps oriented. So we can talk a little bit more about those two concepts maybe, and then we can move into the DevOps stuff if that's okay.
Yeah, definitely, yes. So this is you mentioned that this transformation happened like almost roughly about a quarter century ago, and we're still following and sticking to it because it works, right? Because for we learn from it, and I know you said the culture hasn't changed much. That basically means that largely the idea is to use to follow a model where we have smaller teams and we have we transformed as a microservice architecture. However, there were probably potentially smaller corrections that were made because based on learnings that we had. That is bound to happen.
Yeah, the core is there. I think what's changed since then is everything's bigger. Everything is much more complex because Amazon is such a big company now, and we have tens of thousands of engineers and engineering teams, and we have all these different products. And AWS itself, right, even as a smaller part of Amazon, is now a significantly different kind of business to what it was even 10 or 15 years ago when I joined. But yeah, the practices have evolved, but it's still fundamentally a DevOps culture in the company. We've just had to deal with a lot more complexity, a lot more scale, a lot more volume, and we're also continually raising the bar in terms of like trying to improve the availability of our services and give our customers a better experience. This slide actually just has kind of the text. It's not a verbatim copy of the mandate. I don't think the mandate was ever written down at the time, but gives you an idea as to the principles that were kind of brought into play back in 2002 for us to kind of transition to this microservice architecture. And a lot of these principles still exist in AWS, right? And they're one of the reasons why we've been able to scale what we do to the current kind of size of the organization and still be kind of agile and iterative.
Got it. So this talks about the API mandate. That means every single endpoint, every single piece of software that we write has an API, right?
Yeah.
So
everything has APIs. So the idea of like building like a database and then giving everybody unfettered access to the database in order for them to kind of get data, we don't do that, right? We build microservices that abstract the kind of implementation of something like that, and then we allow other teams or other services in the company to use that service as opposed to going directly to the data. Because if you give people direct access to some backend data store, you're basically pinned to that implementation. You can't necessarily iterate and replace one data store with another one without actually having to go back to a bunch of people and ask them to do work, which doesn't scale in AWS. Yeah.
Got it. Got it. That's really important for these different microservices to sort of collaborate, right? And you talked about initially, you mentioned about teams that are smaller, like two pizza teams, etc.
Yeah.
And with so when you say all of them have APIs, they all communicate with each other through APIs. But when it comes to like teams per se, or maybe you can expand on this API first.
Yeah, even before we get to the teams thing, I should probably call out a couple of things about these APIs. So when we build microservices in AWS, so obviously there's the services that we provide to our public AWS customers, and there's now hundreds of them. So I'm sure all the people on this call are familiar with some of them. Hopefully you haven't used them all. That would be amazing if you have. But when we're designing our microservices, regardless of whether they're an internal microservice that's kind of supporting various different parts of AWS or Amazon, or regardless of whether they're actually an AWS service, we always assume that the customers of those services are going to do the most weird and the most wonderful things with our APIs. So like we can design the API thinking the customers will do X, but actually when you release an API like that, what you'll always discover is customers will do other things with your APIs that you weren't anticipating. So maybe one of the principles that we have is that we protect ourselves, right? So we build our API, we design our APIs, but from an implementation perspective, we try to make sure that we have mechanisms in place to defend the service from customers, regardless of whether they're malicious customers or whether they're just a customer that has decided to do something with the APIs that we hadn't thought that they would do, right? The other maybe principle is that we try to lower the bar to using a microservice as much as possible, so that internal customers or external customers can very easily onboard and start using an API. Because if that's too difficult, then customers will go somewhere else, right? They will either end up reinventing the wheel themselves, or they'll go and find some other service that's easier to use than ours.
So, John, you mentioned two pizza teams. So when I first started at AWS, I didn't really know what that meant. Like, do I have to eat two pizzas? Do we share two pizzas? None seems fair. Do you want to tell us more about what that actually means?
Yeah, and it's an interesting one. So for as long as I've been in Amazon, these two pizza teams were the owners of services, right? So the whole idea here is that it's pretty much impossible for any one developer or one engineer to understand a significant part of something like AWS in terms of its implementation. The only way that you can scale the engineering effort is by creating teams that basically own their part of AWS, their APIs, and they become the domain experts in implementation for that particular service and adding more value to it and adding more features to it. And there's an overhead, even within a team, there's an overhead in terms of like communication, that if a team gets too big, you actually lose efficiency because the communication overhead within the team becomes too high. So the two pizza team is based on the principle that a team should be feedable by just buying two pizzas. That should be enough for the number of people that are in the team for lunch. They might have to be two big pizzas, but the principle is that like kind of under 10 people is kind of like a fairly good kind of guideline in terms of how big one of our typical software development or DevOps teams is. One of the other interesting things about these teams is they don't just build the software. They don't just design it and build it and hand it to somebody else. Most of our teams are actually also responsible for on-call. Most of them are responsible for working on customers' kind of feedback. We got a very direct line to our customers. But these teams generally allow kind of focused innovation in a particular domain. It is interesting that initially the two pizza teams, like way back in 2001 and 2002, they were more project teams. They were actually tasked with improving a particular metric, like page load latency on the retail website or something like that. that can work, but these kind of project teams tend to not have as strong ownership because they end up going all over the place, touching lots of things, and then kind of disappearing again. So the service-based two-pizza team is the model that we kind of follow pretty rigidly across AWS. Yeah.
And I love that idea. So I used to work in a team where it wasn't you build it, you run it. So I was responsible, to responding to problems out of hours, and I had to wait till the morning for somebody else to fix it. And I think when you build it, you run it, you tend to obviously then own it, and you probably don't build something that's going to break.
You care a lot more about the customer experience because you're potentially the one that's going to get paged at 2:00 in the morning to answer a question or deal with some issue. So for sure, it breeds much stronger ownership. Yeah.
Right. And also these teams, just asking if this team thinks that, okay, using a specific programming language or a framework is more suitable for their thing, they can use that, and they don't have to rely on another team telling them, or organization-wide implementation of something to a large extent, right? So they can optimize.
They can even implement Scrum or Kanban, whichever way suits them the best, given their current kind of workload or whatever. We don't mandate everybody does Scrum exactly the same way. We don't even mandate Scrum, right? People can use Kanban if that's the best way for them to get their work done. Yeah.
Got it. And although these applications or individual components are built by these smaller teams, but the endpoint standardization that has to exist itself. I mean, the standard protocols and stuff like that for communication between these microservices.
Right. Yeah. So we have all sorts of standard frameworks that we use. We have all sorts of standards for creating APIs for public-facing AWS services. But again, even for the APIs that a customer sees, that's basically a microservice, right? There's always one microservice which is acting as the front door. It's kind of like turtles all the way down. Customers might see a microservice or a service called CloudWatch, but actually under the covers, CloudWatch is actually implemented by lots of microservices that each deal with different types of requests. Yeah.
Great. So having said that, what are some of the important, some key DevOps pillars that you have in your mind?
Yeah. So this is based on my own personal experience. I'm sure if you go to other people in Amazon, they might highlight a different set. But for me, the most kind of important best practices that I've seen being successful in Amazon, and probably the ones that have enabled AWS to kind of grow and become the business that it is now. Obviously, we talked about microservices already. The second one that's on this slide, the automation, is just so important, right? You kind of can't really do DevOps without having automation, because if you have to do things manually, then you're going to spend an inordinate amount of your time just doing kind of repetitive work manually, and humans make mistakes, right? So for AWS, given the complexity of our system and the scale of our system, the fact that we run, for 30 or 40 regions and hundreds of AZs, and services that run on thousands of compute instances, we have to automate everything, right? Not just from a scale perspective, but actually even from a security perspective, right? There's certain things that we just can't allow human beings to do in an unautomated way. So automation is probably the number one with best practice. Automate as much as you possibly can.
If you can automate, just automate, right? So don't let
it's rare that the investment's not worth it.
Right.
So continuous integration and delivery is a good example of automation. Infrastructure as code is another one. We'll talk about a couple of these actually, maybe in a little bit more detail. I personally work on CloudWatch, which is an observability solution. It's the observability solution that AWS provides to its customers so that they can see what their workloads are doing on AWS. It's also the solution that Amazon uses internally for monitoring all of the various different parts of Amazon. Let's see what else. Platforms and frameworks, you've got to invest in those, and you've got to have some mechanisms and some kind of policies or processes for continually improving. How do you actually take feedback and actually incorporate it back into your services? And then for incident management, we just have to have certain kind of communication and collaboration tools. We can talk about those a little bit as well.
Right. So when you talked about continuous improvement, so monitoring and observability is so critical
Yeah,
for that, right? Like you really need to know what to improve, and in order to know that, you have to really collect the signals, collect the data,
right.
so you can understand where you're lagging, and so you can make
Yeah,
improvements.
yeah. Like it's the nature of the business, right? We work in offices that are corporate offices that have teams of engineers, but our workloads run in data centers all over the world. And the only way that we can know what they're doing is if we've instrumented them, and we can actually remotely kind of view what the services are doing and how customers are using them. So yeah, the instrumentation monitoring is again another one of those kind of non-negotiable pillars, I guess, for being able to do DevOps. Right? It's not like we're all sitting right in front of the server that's actually doing the work, and we can just go look at it when we need to.
So, John, you mentioned the two pizza teams before and how each team is responsible for looking after their own kind of service API. But how does it work in terms of like deciding how to implement each of these, best practices or pillars? Do they all like decide on their own like pipelines, their own frameworks, or
Yeah, yeah.
converge?
So we try to give teams flexibility in terms of choosing the best tools for the problem that they have to solve. You know, if it's a high performance kind of rule engine, we want those developers to be able to like build systems in Rust. If it's a it's a website, we want them to be able to use TypeScript and JavaScript based systems. If they're building like orchestration systems, we want them to be able to reuse kind of third party open source engines rather than reinventing those wheels. But fundamentally, all of these teams still need to do the standard kind of DevOps processes of building their code, testing it, releasing it, and monitoring it. And that type of infrastructure, the kind of the pipelines, the CI/CD pipelines, we don't want all of our teams to have to reinvent that wheel, right? So we do have centralized investments in creating CI/CD systems, for example, that teams can all use. And there's a few reasons for this. One is, it would be too much overhead for every team to learn how to administer a CI/CD system and run it. But secondly, we do things at a scale and with a certain complexity that we need to incorporate, I suppose, improvements to these tools all the time so that everybody benefits from them. So if we find that a certain risk exists in the way that code is being deployed, then we want to make sure that we can actually address that risk kind of in a central way, and everybody benefits from that. So when we find that teams are doing like what we call undifferentiated heavy lifting, right, when they're spending an inordinate amount of their time doing work that's not really their kind of core business, that's when we decide to centralize and actually create solutions within Amazon that will solve that problem for all of the teams within the company. So, like for example, CloudWatch is a good example. We don't want every team in Amazon to be running their own monitoring system. So we provide that to all of the other teams in the company, and they can just use CloudWatch to monitor their systems.
Right. So I think it's not just okay. Because you are independent, you just go build everything. We're just applying common sense. Hey, what is the most what is the one that adds the most value here? Like what is most unique about executing in that team, and you own that fully. But if
Yeah.
there is something that is like the example that you gave about the deployment pipeline, or maybe you were building out an entire region, those kind of things can be shared. And in fact, by sharing, we can also learn from what the other teams want, and we can optimize different scenarios. So that actually benefits a lot of teams, right?
Yeah.
And I'm guessing that is one of the ways. So what is there any other like kind of like signals that we kind of use to build this central tooling?
We use metrics, actually, funnily enough. So like we look at how much time developers are spending, on these various different tasks that they have to do in order to do their core job, which is deliver value to their customers. And when that gets to a certain point and we realize that actually we are better off kind of centralizing that effort and just solving that problem in one or two places instead of everybody solving it themselves, then that becomes part of the overall plan for the business. So we use a lot of data. I mean, we'll probably see this later on, but Amazon is a pretty metric obsessed company. So there's a constant feedback, from our internal customers and from our public customers about what they need of our services. We don't use a lot of, I suppose, commercial off-the-shelf third-party solutions for our DevOps tooling. Not because we don't like them, right? I mean, a lot of these tools are amazing, but actually a lot of them can't quite work at Amazon scale because we literally have probably one of the biggest compute platforms in the world. And as well as that, a lot of them don't necessarily have the features that fit very well for, the kind of slightly peculiar way that we do things in Amazon. And we also like to try and have control over like the pace at which the features that we need are delivered, right? And we've found over the years that for certain things like CI/CD, the only way that we can actually get the features that we need is if we own the solution ourselves, as opposed to having like a commercial agreement with somebody else to deliver them. Yeah.
Right. I mean, it's basically sorry, Anya. It's basically a buy versus build decision, right? Like that's basically what.
Yeah.
Sorry. Yeah, Anya. Sorry, I interrupted.
Oh no, it's all right. So I was wondering, like, so if we build our own features, how do they inspire us to then like what to build for our customers in terms of like requirements?
Yeah. So a lot of the time, I suppose a lot of the AWS services that people see now are derived from or were heavily inspired by something that we had to create in Amazon to solve the problem for, the AWS itself or for the other parts of Amazon, the retail site or whatever else. So like an awful lot of the AWS platform is kind of heavily, obviously it's inspired by what our public customers are asking us for. But a lot of it is also derived from solutions that we had created sometimes years beforehand in Amazon. And when we design our interfaces for our microservices in Amazon, we do kind of consciously design them so that we don't imply in the service interface that the only person that's ever going to use this is somebody in Amazon, because we're kind of looking ahead to what if this ends up evolving into an AWS service? Well, then, here's the right interface for this service, that's not kind of intrinsically tied to the way that Amazon does stuff. So we'll sometimes abstract stuff. That's kind of a natural, organic kind of process, right? The most used, the most successful, the most reliable kind of internal microservices that we think have a reason to be an AWS service, like that we think that there's actually demand for them outside of the company. They're the ones that I think generally tend to evolve into becoming AWS services in their own right. Yeah,
that makes sense. So if you've like felt the pain, you want to make sure that you can give somebody else a solution as well.
Yeah, I was going to ask. So, as an outsider, if I put myself into the or if I heard everything that I just said, there are different teams. They're siloed. They're basically working. They have a task there, or maybe identified a problem they're solving, and the same problem could have been identified by other teams. And are we concerned that there is duplication, there is redundant work, or that's happening across the company or across teams, right?
Yeah. We're not that concerned. So there's this kind of famous line from an old VP, an ex-VP of Amazon, which was like based on a conversation with, I think, Jeff Bezos. and they were talking about should the company like introduce kind of like a top-down kind of structure in terms of like planning what services to build and so on. And the feedback was basically that, well, not having any solution is bad, right? So zero is pretty bad. Having two solutions for a problem is better than zero, right? So we should strive to enable the various different parts of the company to innovate and solve problems in parallel. If we end up with two solutions, that's still better than none, right? The ideal scenario is that you got one, right? So you end up with this kind of weird paradox, which is like one solution is better than two, which is better than zero. So that's kind of the thinking that drives a lot of the organic innovation across the company. We don't deliberately stop these things from emerging. What we find is that the better services are the ones that tend to naturally attract more usage, right? And they're the ones that kind of evolve faster. And generally speaking, over a period of time, the better services will kind of not necessarily win, but they'll become the one, right? And the other services will the usage of the other services will fall away.
Right. That'll prevail, and the one that was not, there was maybe in some ways that did not fit the bill, maybe will give way for the other one to thrive. Sorry, Annie, go ahead.
No, so when I talk to my customers, so there's like challenges normally around using multiple tools. So very often customers ended up with lots of different tools, different services, and they kind of don't really, feel like that works for them, that they want to reduce them to one. But sometimes that's not possible. Sometimes actually trying to fit everything into one tool doesn't work either, because there's going to be somebody out there that's just really not going to be able to do the job. So how do we decide whether to keep like investing in certain tools, etc.?
Ultimately, it all boils down to customer obsession, right? I mean, I think if we try to do our best by our customers, and generally speaking, if there's a better service, customers will gravitate towards it. If there's still customers using another service, then we'll support them for as long as we need to. Sometimes we might run a program internally, for example, and say, listen, you might not be aware of the fact that you've been using that service for a very long time, but actually there's a way better one over there. And if you actually migrate to that, you're going to get, more scalability, higher availability. They've got some features that this one doesn't have. But generally speaking, that tends to happen pretty organically. Yeah.
Got it. So how important is monitoring and observability for for DevOps in AWS? I know we kind of touched upon that a little bit earlier. They're like, oh, in order to improve, we have to collect the signals.
Yeah.
But how important is it? Like that, in your point of view?
I think it's like critical, right? I think if you can't see what's happening in your system, then you don't really have observability, and you can't really reason about what your customers are doing or what they want or how you can improve the system. I've worked in software for probably 30 years now, and I joined Amazon 15 years ago. And one of the most immediate things that I realized when I joined the company 15 years ago, and it's still true, is this company is absolutely obsessed with metrics. It's obsessed with measuring everything, because that's the way that the company actually makes decisions. It's all based on data. So from a DevOps perspective, for our teams to understand like what they should do, this metric data is just critical. It's right up there with automation, right, in terms of like enabling DevOps culture within the company. We obviously have operational metrics that our teams use to figure out what the services are doing or what our customers are doing. But a lot of those metrics are actually also useful from a business perspective. We also have team metrics. We have metrics about individual contributors, and we have surveys that we run across the org to try and understand, are we servicing the needs of our DevOps teams with the centralized solutions that we have, or is there areas that we need to invest in to make each team's lives better? But yeah, metrics and observability is kind of critical to not just operating services, but actually just knowing what to do next. Yeah.
Right. And also like things, things, no matter what we do, like, yeah, that's, I was gonna say this, like
Yeah,
things fail all the time, right? Like Werner Vogel's, our CTO, kind of says that pretty much every single time when he's on
right.
the reinvent
Yeah,
stage.
and this is a principle that kind of underpins a lot of how we design our services. From a development perspective, right? We know that power will fail. We know that availability zones will fail. We know that servers will fail. We know that our software will fail because we've done something wrong in terms of the implementation. We know that our dependencies will fail. Like, so even if we have our microservice and we depend on other teams and other services, we expect them to fail. So that's a large part of the design and development kind of process is recognizing the failure is inevitable, right? And ensuring that we do our best within each of our services to tolerate the types of failures that can theoretically happen, because anything that can theoretically happen will eventually happen. That's at least my experience anyway in AWS. So that's kind of another one of these principles, I suppose, that we assume is true, right? It's something that we just know is going to happen.
Right. So, and that is also like there lies the importance of monitoring and observability, right? So
Yeah.
monitoring and I mean, yeah. So what is the difference there, like between monitoring and observability? There's a lot of people have a lot of theories, and
Yeah. So like 10 or 15 years ago when I started here, monitoring was the thing, right? So everybody actively monitored their systems, and the whole purpose of the monitoring was just to tell you whether the system is working or not. So configuring alerts and getting notifications that something is wrong and that you need to go and fix it. It's something that you do. It's a practice, right? Observability is probably the next level above that. Observability is basically enabling you to kind of ask questions about the system and get answers without necessarily having to tear the system down and actually do something weird and wonderful to try and get the information that you need. So observability is a little bit like testability or security, right? It's an attribute of your system that you either have it or you don't. There's varying degrees of observability, right? But ultimately, they're both underpinned by instrumentation, right? You'll instrument your services, and this is another thing that it's kind of a standard practice for everybody that's building any service, any DevOps team that's building services. They all instrument their services heavily. Sometimes they'll add a lot of instrumentation that they don't have an immediate need for, but actually turns out later on to be very useful because they may have questions about the system that they didn't think of, when they were originally building it. So that's basically, yeah. Instrumentation is the thing that actually enables both.
right. And we collect a lot of metrics when we instrument, and and you can look at it differently, and there are certain types of statistics, like metric statistics, that say different kind of story, right?
Right.
And can you expand on that?
Yeah, so we kind of have a mantra in Amazon that because everything fails all the time, looking at them like the maximum or the P100 statistic value for a metric can be maybe a waste of time, in the sense that if you're looking at the latency of a service and the service is running on whatever 1,000 hosts or 10,000 hosts, and one of those hosts fails in the middle of processing a request, then that host is probably going to emit a latency metric that kind of is unnatural, right? It's like it might be one request out of like 10 billion, which suffered latency that was, say, 10 milliseconds or 10 seconds instead of 0.01. So we learned quite a while ago that looking at the maximum kind of statistic value for operating our services can not really give you a clear idea as to what's happening. If you look at these percentiles, if you look at what's the experience for 99% of customers, what's the experience for 99.9% of customers, then that can actually reduce the noise quite a bit. The other reason we look at these percentiles is we want to make sure that we don't obsess over averages, because we don't. It's not really good enough to obsess about like what your average customer experience is when that means that like half of your customers are having a really bad day, right? So we also look at these percentiles because we look at averages. Averages are quite useful for calculating capacity for our systems, but the percentiles are much more useful for actually really looking at what the customer experience is.
Got it.
That makes
And
sense.
also yeah, good on you.
Sorry. So talking about noise as well, can you tell us more about kind of alerts as well? Because I talk to customers all the time, and a lot of the time they have like lots and lots of alerts on lots and lots of metrics, but then they don't really know what to do, or they don't really do anything about the alerts. So
Right. So you end up suffering from like alert fatigue, right? Because people just start kind of stop paying attention to them. Yeah. So curating alerts is kind of a never-ending process, right? That's not something that you can just do at the design stage for a service. It's something that you'll certainly start the process when you're designing and kind of building the service. But what we found is that it's really only when you start operating the service that you know which are the alerts are the ones that actually you want to keep, and which of them are just noise. And we find that our DevOps teams are continually refining their alerts, because we look at our service performance kind of on a weekly basis or a daily basis, and they want to tune their alerting. Well, number one, they have to have alerting because they just can't look at their dashboards all the time. Right, so you have to have automated alerting, but it's really super important to make sure that like you're continually investing in the alerting so that your operators don't develop alert fatigue. Because when they develop alert fatigue, then what happens is, legitimate kind of impact issues actually you start missing them, right? Operators, they're human beings. They can't kind of filter all the noise, and still see the real issues. So constant alert kind of maintenance is a must-have. Yeah.
yeah, but I used to work on a service that was really, really busy and received like I think 4,000. I mean, obviously it's different for AWS, but we received 4,000 requests a second. We thought it was a lot,
Mm,
but we actually had very few alerts, and that's because we only responded to stuff that was genuinely an
customer.
alert.
Yeah.
Because otherwise, I apply the rule: would you get out of bed for this, or would there be like customer impact, or is this
Yeah.
just something that's information?
Yeah, we have alerts like that, but we do have other alerts that are like lower severity that are kind of warning us about kind of potential capacity issues in the future. So we don't want to be trying to kind of calculate or do any of that manually. We use our alerting system to tell us when that's going to become an issue in the future. Yeah.
But if you're going to ignore it, then it's probably not a.
Yeah, once an alert gets to the point that people are ignoring it, then it's useless. Yeah.
I agree.
Yeah.
Right. I was going to ask you, but you did mention when you were talking earlier that we learned a long time ago that something is important, like how to ignore that. We can totally ignore like one request that is taking much longer than others, which is like an outlier. No, not something you need to immediately address. Like how is like the knowledge sharing across teams happen? Like right, so although we are individual teams, there could be opportunities where we have learned something, and we don't want other teams to repeat the same mistakes, right? We want them to learn.
Yeah, there's a few pretty strong mechanisms in AWS for this, and I can talk through a few of them. So one of them is this like weekly ops meeting culture that we have, where individual teams will meet on say like a Monday, and they'll review the performance of their service over the past week, and they'll talk through their dashboards, and they'll answer any questions that people have about what happened during the last week. After that, then maybe on a Tuesday, the larger organizations will do that exercise, and they'll kind of look across their maybe one AWS service, for example. And then on Wednesday, we kind of roll up to this AWS Ops meeting, which has been running for as long as I've been in Amazon. And there's a few things that happen at the AWS Ops meeting, but one of the interesting ones is this wheel Used to be a physical wheel in a room in Seattle, but actually AWS got so big that we couldn't fit the names of all the services on the wheel. So we created a virtual wheel. So actually, if you scan the QR code, you can get a link to a blog entry. It's open sourced. So we basically, what happens is every Wednesday, there's a meeting where we talk about operations in AWS for the previous week. And one of the first things that happens in that meeting is that we spin this virtual wheel, and one or more AWS services will be picked. And that service has to present their dashboard with, during the meeting. Now, it's not the type of thing that you want to find out that your name has come up and then you have to kind of go and look at your dashboard and try to figure out what happened last week before you have to present. All of the services are ready to present before the meeting happens, even if they don't have to present, because for time reasons we can't ask them all to present, but they could all be asked. Each of them could be asked, depending on the wheel spin. This kind of creates that muscle in the company that, like, on a weekly basis, everybody is prepared to talk about what happened in their service during the last week.
Could you be super lucky and get picked like 2 consecutive weeks?
Yeah, if you did, they'd probably just pass and they'd just spin the wheel again. There's not that much point in looking at one service twice in 2 weeks.
Right. Yeah.
That's one of the muscles. The other one is this kind of post-mortem culture we have in Amazon, which we call.
Sorry, John. Like, we have a question on the chat. Like, I'm going to put it on the screen. This is, before we go. This was about alerts, so I just want to make sure that that's addressed. It's about, do SLOs help with alert fatigue and focusing on customer impact? Like, how do we balance that? Like, versus
They do help. Yeah, no, they do help, because SLOs are very much oriented towards measuring your customer experience. And obviously, if you have an alert that's configured on an SLO, that's something you should care about a lot, right? Because your customers are probably having a bad day. So creating alerts that are aligned with your SLOs is almost like mandatory, right? There's not much point in having an SLO if you're not actually alerting on it and you don't know when you're breaching it. They're probably the most important alerts that you can create. The other alerts are probably more internal, right? They're the ones that'll maybe give you more of a clue as to where the problem is, as opposed to telling you exactly what the customer impact is. Yeah.
Got it. Okay. Sorry. Let's keep going with the learnings. Right.
Right. So corrections of errors. So we call them corrections of errors, and the principle here is I don't know if people are familiar with this open disclosure principle, but if you read anything about like the health insurance industry, there's certain hospitals have this kind of open disclosure policy where if there's an incident, they will publicly document what happened, and what they tend to find is that the insurance costs for those hospitals tend to be lower, because by publicly disclosing what happened, they create mechanisms to stop these things from happening again. Other people learn from them. In Amazon, again, for as long as I've been here, we kind of follow a pretty similar practice where if one service team has a particular event and we think that there's something to be learned from that, or we think that there's actions that need to be taken to prevent that from ever happening again, then we have a kind of a document format that people use to basically write up an open disclosure of that event. And we review these at the ops meetings. And there's probably a few things in these docs that is kind of interesting. Again, they're very customer oriented. Their purpose is to try and explain what happened, what the customer impact was, what the timeline was, what actions the operators took during the event. But probably the most important sections are the lessons learned and the actions, right? And the mechanism is good because it's not just a Word doc that gets kind of thrown around the company. It's built in a tool. The actions are tracked, so they have dates. And we use this a lot to share learnings from one team with other teams in the company. Sometimes the actions actually trigger improvements that we will push across all of the services, right? Because we know that can actually help them. Yeah.
Are there other mechanisms like this?
One other one is like operational readiness reviews. So this is kind of like a pre-mortem, I guess, is probably the best way to describe this. So when our DevOps teams are actually creating something like a new feature or a new service, one of the things that they do, obviously in parallel with actually implementing it, is kind of go through this kind of review process, which is like, hypothetically speaking, when this feature exists in production, how will you do deployments, right? How does this feature or this service defend itself from kind of abuse? What dependencies does it have? Are you aware of the kind of availability of those dependencies? Do you have the runbooks that you need in order for the operators to be able to run the service? Are you doing backups? It's kind of an interesting, obvious question. But a lot of these questions are actually kind of common sense things, but it's basically a checklist for the service teams to ensure that they're thinking about everything that they should be thinking about while they're developing the service. These are not questions that we want them to answer or even start thinking about when they're about to go into production or when they're in production. We want them thinking about these and addressing them while they're actually building the service. Yeah.
Got it. And we for us, security is job number one. I'm guessing that we also have security reviews and
Yeah.
in addition to operations, right?
Yeah, like security is probably the number one tenet in AWS. So we have very strong mechanisms to kind of make sure that as we're iterating and innovating, the features and the services we're building are secure above, and like that's probably the most important thing, right? If we don't get the security right, then the rest of the value of those features is kind of meaningless. So we have obviously very strong mechanisms to ensure that we kind of don't assume that every single development team is an expert in security. It's very hard for every software developer and every team to be a security expert. So we basically provide security expertise to all the teams so that they can actually maintain a high bar and a consistently high bar for security across all of the things that we do. Yeah.
So with everything at AWS constantly changing, we're always innovating new services, new features, new regions, and fixes. So with all of this, all of the time, so how do you actually control that?
We eliminate manual work, right? The only way to do it is to automate.
Automate.
Yeah,
it goes back to the initial slides.
Right. And like it's automate for efficiency, but it's also automating to make sure that like the services are kind of autonomic in the sense that like they can automatically scale up, they can automatically scale down, so that we're not kind of wasting resources and end up charging customers for too much because we're not being efficient. But yeah, ultimately, the only way you can operate at scale and the complexity that we do things is to eliminate pretty much all of the manual effort in terms of doing routine deployments. So we have change management tools, that are basically automate as much as possible. There are some changes that are just by their nature, it's maybe necessary to have a human that's kind of like working with the tool as opposed to just a completely automated thing. They're kind of rare. Most of our deployments are completely automated. There's probably a few interesting things about our kind of change management system. One of them is, one of the principles we have is that like any change that we're deploying we have to be able to roll it back. Right? We do not like any change going out that cannot be rolled back, because inevitably, it may need to be. And you don't want to go through that one-way door where you've made a change and now you don't know how to undo it. So we have to prove that changes, the teams have to prove that changes going out can be rolled back. And then the second probably really important thing is that the deployment system is tightly integrated with our monitoring system. So as deployments are happening, the monitoring system is aware and kind of pays particular attention to the metrics that service is emitting during a deployment, so that it can actually detect anomalies that might be because of a new code path, for example, that weren't there before. So that integration with deployment and the the monitoring system is super important.
Alexander on the chat asked this question, John.
Yeah, what if a change requires state mutation? So they're the types of changes that you're right. There are some changes to the system that are one-way doors, right? That are kind of, but we do pretty much as possible to try turn them into like 1 or 2 or 3 step deployments, where we won't necessarily like affect the entire change in 1 step. We'll try break it down into 1 or 2 or 3 steps so that we can actually incrementally deliver the change. And then once we're happy that like the schema has evolved, then we'll maybe make the final change, which will drop something that was there before that we don't need anymore. There are ways of managing that. Yeah.
Cool. So the next thing I wanted to ask you about is capacity planning. So how do the DevOps think ahead and think about that?
Yeah, like the short answer here again is it's all based on instrumentation. It's all based on metrics. We build internal tools that use kind of a lot of the same metrics that we use to operate the service to do capacity planning. The only extra complication here is that you have to employ, some kind of ML models, or you have to employ some kind of more advanced maths to actually figure out or predict what's going to happen in the future, and then kind of do your capacity planning based on that. Yeah. Scale testing helps as well, right? So if we do scale testing, that'll help us validate that our services don't have limits that we don't know about. Yeah.
And we also like anticipate failures, like forcefully.
Yeah. So
issues.
So chaos testing, and this is an example of maybe one of those things that we were doing internally before we turned it into an AWS service. So like now you can use fault injection service. It's an AWS service for doing this, but we've been doing this for a long time. It's like deliberately inducing failures in our system in a kind of a controlled way, and then measuring the effect of that change and checking whether the system reacted exactly the way we would expect it to. What we're trying to find is, I suppose, regressions that shouldn't be there, that actually put the kind of availability of our service at risk if certain failures occur. Yeah. So we do this kind of periodically so that we can actually, it's much better to find out about these types of regressions in a controlled way when you're actually running an experiment than to find out, at some random time when you're not prepared. Yeah.
Right. Yeah, I 100% agree with that. I cannot stop myself from asking this question. So we had talked a lot about siloed teams, individual teams, all of that. But let's say, incidents happen all the time. Everything fails all the time, right? And when a large scale event happens, it's not just one part, the one team's feature or component that goes down, right? It has sometimes there is cross effect. How do these teams all of a sudden function in a different fashion, like work together to solve that? That's what's the magic there?
It's a combination of things. So there's, we invest pretty heavily in creating like an incident response function or kind of a capability within the company, so that if something occurs, then everybody knows exactly what to do, right? They all have the tools that they need to collaborate. There's, whatever it is, video conference bridges, there's tickets or kind of, issues that people can contribute data to. We use a combination of video, voice, tickets to actually kind of collaborate. Probably one of the things I think that enables us the most is visibility, appropriate visibility into each other's services, so that, if I depend on some other service, if my microservice depends on some other microservice, then I don't necessarily have to speak to a human being to find out what's happening with that microservice. I can actually just go and look at their SLAs or their SLOs and their performance, and I can actually see whether they are the cause of my problems or whether it's somewhere else, right? So, so kind of building that accessibility to each other's observability data is pretty important in terms of like enabling that kind of fast collaboration. We do a lot of that through dashboards. So, each of our service teams kind of create, part of their role is to not just create dashboards for themselves, but also create dashboards for their customers, so that their customers can see whether their service is operating the way it should be. Yeah.
So when you say customers, are the teams, right? I mean,
Other teams,
that
yeah,
is
my teams,
consuming your services.
yeah,
So
yeah.
that way I can see the dashboards of their dashboards as well.
Not all of them. I mean, there's probably too much detail in a service team's dashboard that you wouldn't understand it. But there's always one dashboard which is kind of like their SLAs or their SLOs and how they're currently performing relative to their kind of availability expectations. Yeah. So I wrote an article about writing dashboards a couple of years ago that anyone can read on the AWS website. It just talks a little bit about how to kind of approach building dashboards for microservice-based architectures, and the top dashboard, the most important one, is the customer-facing dashboard. The rest are all there to try and support the team that own the service in terms of operating it and dealing with issues and doing capacity planning and managing their infrastructure. Yeah.
I think you're being quite humble, by the way. I think it's my favorite builders library. Yeah.
I should plug, by the way, before I know we're just about time, but I'm going to plug the builders library so that there's a lot of PEs, or principal engineers and distinguished engineers in Amazon or at AWS have written a bunch of articles. Some of them are about how we design our services, and some of them are about how we kind of do things like continuous integration and continuous deployment. If you're watching and you haven't if you haven't seen this builders library before, I'd probably recommend looking at it, because there's a wealth of knowledge there about not just how we do DevOps, but actually how we design our systems. And I think it's probably one of the most kind of under kind of appreciated kind of knowledge bases in the AWS website, that anybody can read it and actually apply some of these kind of principles to the design of your own services. Yeah.
You don't know how many times I've shared the dashboard article of yours, like Anya mentioned, to any customer that asks about it. That's the one, and because it is so useful. It's very specific and
That's
very thoughtful.
pretty much based on what we do in AWS. So it's based on, I suppose, years of experience in terms of what type of information you should put in dashboards and where you should put it. Yeah.
Right. Are there other such articles on the?
Yeah, there's a few others. So on the DevOps kind of topic, there's articles about how we think about CI/CD pipelines being our release captains. David Janacek, one of my kind of colleagues, has given some amazing talks at reInvent. One of them is about how we do operational excellence in Amazon. It's probably worth a look as well. It's indexed in the builders library, so you can find it there. From a design perspective, it's not quite just DevOps, but it's more about how we design our services. But we describe how we think about managing kind of overload in our services, and kind of preempting overload. I suppose we just don't want overload to happen in the first place. How we build multi-tenant services that actually can safely accommodate customers that have millions of requests per second or 10 requests per second. So that's two. And then, avoiding overload and dealing with queues is kind of another kind of standard complex challenge that everybody has when you're building distributed systems. There's a lot more. Yeah.
Yeah, the whole, like you said, the builders libraries is such a it has such wealth of information that people can actually leverage. But I know we are 4 minutes over, but I think we'll still go one more minute, I guess. So there's a lot of information here. This is great, and there's a lot to digest. If I'm a startup, right, should I just go like watch this video and you just copy everything? Is that the right thing to do?
I mean, I would say yes, in the sense that none of the practices and none of the principles and the things that I described today from a DevOps perspective, they have all proven to be super valuable, right? So investing in automation, investing in testing, and all of those things, building these kind of pre-mortem, post-mortem kind of mechanisms into your company. I think they're all worth doing. I would say that maybe we're dealing with maybe slightly more complexity, right? We have such a big estate. We have so many customers. We have all these kind of geographical regions to work with. Hopefully, AWS is actually solving some of these problems for you. We've released services that make it easier for you to do DevOps. Things like fault injection simulator, things like application recovery controller that make it easier for you to get your application out of a bad situation. So I think, yes, I mean, we're a little bit peculiar. We're probably, like I said, one of the biggest compute platforms in the world. If you're a startup, then you don't have to deal with a lot of the complexity that we have to deal with. But the principles in terms of CI/CD, being communication mechanisms that you need between your teams, microservice-based architectures, I think they all apply to everyone. Yeah.
Got it. Makes sense. Thank you so much. Thank you, John and Anya, you too. Thanks a lot for being on the show. I think that this is a lot for all of us, and I think I'm hoping people will make use of it and can implement it in their own environment. Thanks again. Really appreciate it.
Okay. See you, Amia. See you, Anna.
Thanks, everyone. We'll see you all in the next one.